So what about, these are primitives. Now what about if we wanted to store objects in an array? Well, declaration is going to be whatever the object type is. So let's use string, because that's an easy one. String, that's the object type. So we're going to have an array of strings, and we'll just call this words, right? So we have an array of string objects called words, and now we need to actually grab the memory that we need for that. So new string 10. Okay? So that, I'll draw up my array horizontally this time, just for the heck of it. Again, these are just graphical representations of the memory, and it doesn't matter how you draw them. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now we know that when a person makes a new string, it can be of any length. So since when an array is made, it grabs a contiguous block of memory with cells each exactly the same size, how is this going to work with strings? Well, the way it works with strings is that the object itself is not stored within this memory as primitives are stored actually within these contiguous memory blocks. What's stored with any object, an array of objects, is a reference to the object, right? Or basically the address of the object. And since all addresses in a particular version of Java are the same size, these can all be the same size. And they all refer to, let's switch colors just for the fun of it, they all refer off to, so an object, right? Now, they only do that if you actually make an object and put it in there. Otherwise, these are all what? They're all null when you start out. Okay? So, the way we would have done this, let's say this has ABC in it, the string ABC, you can guess how we would have done this. The name of our this array is words, so we would do words sub 0 equals new actually we could probably just do don't need to do new here, we could do words, we could just give it the string A, B, C, okay, equals A, B, C. So that just would it's a shortcut to using new, and sticks the string object ABC off of this memory location. So what's really going on here is this is a chunk of memory is grabbed right there that holds ABC, and the address of that memory is placed into word sub 0 right there, right? And so that has a reference to that object. Now, something that's a little bit different from array lists is that if, say, we filled up this array, all reference to objects, and then we don't even need to do that. Let's just put one more here to illustrate this point. So we have another object here, and this has in it D, E, and F. Now, if this were an array list and we remove this object, we know that everything else, all other objects would shuffle down. But we also know that in an array list, there can be no holes. Well, it's the same thing, right? So there can be no holes, so that this would shuffle down to there. In an array, that doesn't work, which is good for most purposes that we want to use an array for. So that will just, if we dereference that by setting words sub 0 equal to null, right? that becomes dereferenced. The garbage collector would come in and eventually get rid of it. And that reference to the DEF string would not slide down. It would stay right where it is. Right? So for some purposes, that's exactly what we want it to do. Last thing on strings, there's a shortcut for filling strings, for filling arrays. It works like this. So you could do int, we'll give it a different name, nums equals, and then inside braces you just enumerate the numbers that you want to be in the array nums. So you could do 1, 2, 3, and so on, just separating them by commas. And that would create a little array 0, 1, 2, and in that the content would be 1, 2, and 3. Okay, so when you don't do this very often, except maybe when testing new programs, but it's a quick way to fill up an array with some values. It can be useful. Okay, so let's just review this. Right, this is using a new color. This is the key syntax for an array. You break it down into 2 parts. Right, that's the declaration. You write the type, the 2 brackets to indicate that it's not just one of those, but it's an array of those. You give it a name. So that's the declaration. And the actual creation is using new. Again, you repeat the type, and inside the brackets this time you say how big a chunk of memory do you want to grab. Right? And like strings, arrays are immutable. Well, that's not true. I mean, the content of them obviously can be changed, but the size is immutable. Once the array has been created, you cannot change the size. So if you need a bigger array, you're going to need to copy the existing array over to the new array that's of a bigger size. Okay? That's how you access the a particular array position, right? You can use that for assignment, or you can just do it like that if you want to output what's there, get what's there. So arrays can hold primitives, in which case the values are held right in these cells, these memory blocks, because primitives, we know how big they are, and they're all the same type of primitives. If we're using objects, objects can take up different amounts of memory. So what we store in that case is references to objects. In here, the references are addresses, and all the addresses are the same size, so they all take up the same size block of memory. And you can have nulls in here, and things do not move around or shuffle down if you delete, if you remove something from an array.